Hey guys, today we are looking at lesson 2.3, our measures of central tendency and shapes of distributions. So we're going to start out with some stuff that is kind of a review. You've definitely seen these words before in your math classes. There are 3 M words. Mean is the average, median is the middle, and mode is the most. So those are 3 measures of central. And we're going to start talking about the mean. That's our average. So the mean is the sum of all data entries divided by the number of entries. So we have 2 different means, or 2 different symbols for our means. The first one's for population. That symbol right there is the Greek letter mu. So its formula is just the sum of entries divided by the population size. Our second mean is the sample mean. We call this symbol x bar, and it's just the sum of entries divided by the sample size. We will use x bar way more frequently than we'll use mu, but we will use both. But you'll just see x bar more frequently because we work with samples more than we work with populations. So example, finding a sample mean. So we have some prices here for flights, and you want to find the mean. So go ahead and pause the video here, find the mean, and come back for the answer. Okay, so hopefully you guys got a chance to try out this problem. X bar, that is the sum of all of our entries, so we add all those up, and we should get 3,695. And we divide that by our sample size. There are 7 pieces in our sample. And that gives us 527.86. So the mean price of our flights was $527.86. Let's take a look at the median. That's our middle, okay? The value that lies in the middle of the data when the data set is ordered. So it can't just be randomly placed. It has to be from lowest to highest or highest to lowest. It doesn't matter which way you go, that middle is going to be the same either way. This measures the center of an ordered data set by dividing it into 2 equal parts. So when you find the middle, there's 2 situations that you might run into. If the data set has an odd number of entries, the median is going to be that middle number. So if you had 5 entries, that middle one is your median. If you have an even number of entries, the median is the mean, the average of the 2 middle data entries. So if we had 4, you'd have to find the average of those 2 middle ones to find your median. So finding the median, go ahead and pause the video here, find the median of our flight prices. Okay, hopefully you guys got a chance to try out this problem. So the first thing I did was I put all of our numbers in order from least to greatest. And then I just worked my way in and found that middle number. We had an odd set of data points here. We had 7. So we just had one number in the middle. So 427 is our median. Now notice that median is a different number than what our mean was. It's lower than our mean. And then our final thing we're going to talk about is the mode. This is the data entry that occurs with the greatest frequency. If no entry is repeated, the dataset has no mode. If two entries occur with the same greatest frequency, each entry is a mode, and we call this bimodal. Just like a bicycle, two wheels, bimodal, it has two modes. So take a minute, go ahead and pause the video and find the mode of our flights from Chicago. Okay, hopefully you got to try the problem. If we look at our data set here, we see that there's only one number that's repeated, and that is 397. So the mode of our trip is $397. So you'll see that we had 3 different amounts for our trip when we looked at those central tendencies. So our different central tendencies, they all measure the center of your data, but in different ways. They all kind of give you a different insight, and we'll talk about that in a minute. We're going to look at one more example of finding the mode. At a political debate, a sample of audience members were asked to name the political party to which they belong. Their responses are shown in the table. What is the mode of the responses? So go ahead and pause the video here and take a minute to see if you can figure out the answer. Okay, hopefully you guys got a chance to try the problem. Let's talk about it a little bit. This is a little bit different than when we looked at just our numbers listed out, because it's already sorted into a frequency table for us. And remember, mode is the number with the highest frequency, or the item with the highest frequency. So if we look at Democrat, they had a frequency of 34. Republican had a frequency of 56. Other had a frequency of 21. And did not respond had a frequency of 9. So our greatest frequency and our mode would be Republican right there with 56. So now we're going to talk about comparing the mean, median, and mode. All 3 measures describe a typical entry in the dataset. But there are some advantages and disadvantages to them. And the one that's used the most is really the mean. So we're going to focus on those advantages and disadvantages of the mean. So the advantages of using the mean is that the mean is a reliable measure because it takes into account every entry in the data set. Okay? Every single entry in the data set is a part of the mean. You add them all together and divide them, and that's how you find that mean. But that can also be a disadvantage. So our disadvantages of using the mean is that it can be greatly affected by outliers. These are numbers, these are data entries that are far removed from the other entries in the data set. And we've seen some of those in the graphs that we've been talking about. So let's look at all 3 of our measures of central tendencies in this one group of data. So find the mean, median, and mode of the sample ages of a class shown. Which measure of central tendency best describes a typical entry of the dataset? Are there any outliers? So go ahead, pause the video here, and find the mean, median, and mode for this dataset. Okay, hopefully you guys got a chance to find that mean, median, and mode. If you add up all your ages together, divide it by the 20 people in the class, you should get 23.75 as our mean. That would put the mean about right here, very close towards the end of the class. Our median would be 21.5, because when you get down to it, there's a 21 and a 22 right there in the middle. So you find the average of them. And then the mode, of course, is our 20, because there's the most 20s in the class. So looking at where all of our numbers are, I would say that the median is looking like our best measure of central tendencies. And then it asks if there are any outliers. I'm sure when you're adding up your data, you notice the 65. That is far away from the rest of our data in this set. So 65 would definitely be an outlier. So the mean takes every entry into account, but is influenced by the outlier of 65. The median also takes into account every data point, kind of in a different way though, because it just kind of is cutting them out one at a time, but it is not affected by the outlier. So there's a way that we decide if we're going to use the mean or the median. If your data is what we call symmetrical, or it is uniform, you use the mean as your center. But if your data is what we call skewed, or it has an outlier, we're going to use the median as our center. And on the next few slides, we're going to see what symmetrical, uniform, skewed, we're going to see what all that means. But let's look at a graphical comparison first. Sometimes a graphical comparison can help you decide which measure of central tendency best represents a data set. So in this case, it appears that the blank is the best describes the data set. So if you look down at the bottom, we have our mean all the way over here on that side of this cluster. Our median is in the middle of that cluster, and our mode is over here at the beginning of the cluster. So looking here, I would say that our median is the best describes the data set. Because you can tell this is our ages that we just did in our problem above. That gap and that outlier are causing the mean to move far from the center of that cluster. Okay, so that wraps up our mean, median, and mode. We're also going to talk about the shape of distribution in this section. The first one we're going to talk about is symmetric distribution. So if you think about symmetric, you think about symmetry, butterflies, when it looks the same on both sides. So symmetric distribution, a vertical line can be drawn through the middle of the graph of the distribution, and the resulting halves are approximately mirror images. So you can draw a line down that middle, and it looks the same on both sides. You also notice that the mean, median, and mode are all in the same place in a symmetric distribution. We also have something called uniform distribution, rectangular. Entries or classes in the distribution have equal or approximately equal frequencies. Okay, this is just another form of symmetric, because if you folded it down the middle, it would look the same on both sides, but it also, everything across the board is the same. You'll notice again that the mean and the median are the same, and it has no mode because they're all the same number, so nothing has the most frequency. We're also going to take a look at skewed. So first we're going to look at skewed left. So for skewed left, the tail of the graph, that's the short part of the graph, elongates more to the left. Okay, so the tail is kind of when it comes down and goes like that. Also, the mean is to the left of the median. Now, something about skewed is that when you're looking at a skewed graph, you want to think the opposite. So if we look at this graph, most of our data is on the right side of the graph. That means that it's skewed left. If most of the data is on the right, you're skewed left. So for our next one, when most of our data is on the left, then we are going to be skewed right. Because this time when we draw our tail, it is going to elongate more towards the right. Here when we draw it, this time it flattens out here on the right. And this time the mean is to the right of the median. Okay, so you want to think the opposite when thinking skewed. And we also are going to talk about unimodal. Just like a unicycle, unimodal means that you only have one mode or peak. For a peak, think about a mountain. That's just kind of where it crests here at the top. So then bimodal is when you have two modes or two peaks on a graph. 1, 2. And we've already talked about most of these features of a distribution, but we're just going to kind of put some definitions to them. We've talked about gap. That's where you have a missing area in the data set. So it's just a place, a portion of the horizontal axis with no data. So it's any space on the horizontal axis. So right here's an example of our gap. There's no data above the 5, 6, 7, 8, 9. But it doesn't have to be a big chunk to be a gap. It can just be one or two places on the horizontal axis. We've also talked about outliers. They are data entries that are far away or far removed from the rest of the data set. Okay, you can see them over here. Our 10 or 11 there would be outliers. Outliers are always surrounded by gaps. That's how they get far away from the data. And we also have our cluster. Clusters are when data entries are grouped together by proximity. And you can see that in our graph here at the bottom. Everything's just kind of all together, grouped up. And that is the end of our central tendencies and shape.